Let us go through the details about map to project the data. We can use map on top of iterable to return new iterable with all the transformed elements based upon the logic. It takes transformation logic and iterable as arguments. We can pass transformation logic either as regular function or lambda function. Map returns a special iterable called as map. We have to typecast to regular collections such as list to preview the data, or we can use for loop to iterate and print the data. Data from objects such as filter, map, etc. will be flushed out once we read from it. Also, number of elements in the map object will be same as iterable that is passed to it. Because we will not be filtering any data, we will just apply transformations on the elements within the iterable, and hence the map object will contain the same number of elements, but the elements will be transformed based upon the business logic that is applied on each and every record. Now let's run this to make sure that orders and order items collections are created by reading data from the underlying files. We can preview by running these to ensure that orders and order items are read into collections. Now we can actually perform this task in the pursuit of using map function to apply certain transformations. So in this case, we are just trying to get one of the fields, which is nothing but order date from each and every order. For that, the way you can actually apply the transformation logic is just to split the order and then access the second element using the index like this. And as part of the split, we have used comma because our data is delimited by comma. So in this case, I have taken one record from orders dataset and demonstrated about how to extract the date for one record. Now we can apply this same logic as part of the lambda function here, which is passed as first argument to the map function. And then as part of the second argument, we can actually pass orders, which is nothing but a list, which is nothing but iterable. You can now run this and you should be able to check the type of order dates. It is of type map, and you should be able to preview the data. It contains all the dates. You can also use len function on top of orders to ensure that the number of records in orders as well as order dates is same. In this case, if I run this directly, it will return 0 because we have already read the map object here. As it is already read once, when we try to get len on this order dates, it have returned 0. To mitigate this, we have to read it again. As part of our actual application implementation, we will not be previewing like this. We typically pass the map object for downstream processing, and we will process and we will move forward. So we'll not be running into these issues as part of our application development process. But as we learn, if you want to preview the data, you will observe that the objects such as map, filter are flushed out once they are read. That's why we are seeing 0 here. Now we have to read once again by applying the required logic to extract the date. Now we should be able to run len on list of order dates, and we can see 68,883 here. Now if you look at the order dates, we have duplicates. In this case, we might be interested in only the unique dates. For that, we can typecast the collection to set, which will actually give us the unique dates. However, as order dates is already read, we cannot use set on top of it. It will not return anything. You can run this and you can see that it have returned an empty set. We need to create order dates again by using map function. It will actually contain all the dates in that map object by name order dates. Now you can say set of order dates and you should be able to see the dates. You can see all unique dates here. If you want to get the length of this set, you can apply len on set. However, as the data is already read, order dates will be empty and you will be getting 0. To mitigate this, you have to create the map object again by name order dates. Then you can pass it to set. Immediately you can pass it to len like this, and you should be able to see the number of unique dates, which is nothing but 364. This is how you can actually take care of downstream processing of map objects, such as getting unique values or aggregations, so on and so forth. Now, using the same orders dataset, we want to extract order ID as well as order date from each element in the form of a tuple. In this case also, we can use the map function. Also, when we try to get order ID, we will try to get it as integer, not as string. So you can preview first 10 records here. You can take one of the records or two of the records, and this is how the output should be. You should have a list of the elements. Each element should be of type tuple. The first element in the tuple should be order ID. The second element should be date, and also ID has to be integer. So this is the example for list of tuples. This is how I want to get the output. Now you can use the map function. As part of the map function in your lambda, you just have to invoke the tuple using circular brackets like this and pass the elements you are looking for. Order.split of comma of 0 will give us the order ID. order.split of comma of 1 will give us the order date. You can actually copy this from here to here, and then you can add a cell, and then you can actually say order equal to orders of 0. We are trying to get the first element, and then we are converting the ID and date to a tuple here. You can see the output here. The same logic is used as part of the lambda function. Now order underscore tuples is of type map object, which contain the tuples we are looking for. We should be able to preview the data by running this one. You can see that the order underscore tuples contain objects like this, which are nothing but tuples. Each tuple contain ID and date. This is how you should be able to project the data using map function by extracting the elements which you are looking for. As we understood how to filter and also how to project using map, now let's spend some time using map itself about row level transformations. Map is also used for row level transformations, not just for projection as we have seen here. Let's understand how row level transformations can be taken care using map.